Okay, so today we're going to talk about exponents. And here's a classic example of an exponent. Let's say we take 2 to the third power. Now, there's a couple terminologies that you'll want to know. This is going to be called the base of the exponent. And this is going to be called its power. And exponents are an operation. And you need two numbers for the operation just like you need for everything else. So this is my first number and this is my second number. And here's what this means. It means we're going to take our base and multiply it by itself as many times as our power says. So for this example, we're going to take 2 and we're going to multiply that together 3 times. So what this means is 2 to the third is 2 times 2 times 2. Well, 2 times 2 times 2 is going to give me a grand total of 8. And that's the basics behind what an exponent is. Let's have you try an example real quick. So take 5 and take it to the 4th power and see if you can figure out what that's going to equal. Hopefully what you did was you go, oh, 5 to the 4th power. Well, this is my base, and this is my power. So we're going to take 5 times 5 times 5 times 5. Well, 5 times 5 is 25, and 5 times 5 is 25. And 25 times 25 is 625. So hopefully that is what you got for your answer. Let's look at a couple more examples. So that would be with just whole numbers. Let's try it with fractions. Well, if we're going to do this with fractions, again, this now is our base, which that's the whole fraction, and our power is going to be 4. So we're going to take 2/3 and times it by itself 4 times. Well, the nice part about this is, with fractions, you actually just get to multiply the tops together. You get to multiply the bottoms together straight across. And what you end up getting is you get, for this one, well, 2 times 2 is 4, and 2 times 2 is 4, so that would be 16. And 3 times 3 is 9, and 3 times 3 is 9. So then you'll get 9 times 9, which would give you 81. And then we would look to see if we can simplify this fraction. Nothing divides the top and the bottom, so that would actually be my final answer. Let's try a different one. So let's see if you can figure out the answer to this. Well, hopefully you go, okay, well this means 3 over 5 times 3 over 5, which is going to give you 9 over 25. And that would be my answer. Okay, so now we've figured out what an exponent is. We've figured out how to work with exponents when we've been given some fractions. The next thing that we have to do is do the weird cases. So these are called the weird cases of exponents. Here's the first weird case that comes up quite a bit. That negative 3 to the second power is not the same as negative 3 parentheses to the second power. And that looks very weird to say, like, well, it looks like I have this base and it's to this power, and I have this base and I have this power. So, I mean, shouldn't that be the same thing? Like negative 3 to the second power should be the same thing as negative 3 to the second power. Here's the issue with this. The only thing that gets to be included is what's inside the parentheses. So in this one, it's actually, your base is actually 3. So the only number that gets to be included is what's inside the parentheses. So that's why if you looked up top here, I was very careful how I wrote these fractions. I put parentheses around the whole thing. It would mean something different if I wrote this, because that would actually only tell you that the 2 is going to be to the 4th power. So in this case, 3 to the 2nd power, well, that's 9, and I stick on a negative. In this case, I'm going to square negative 3, which negative 3 times negative 3 will give me, well, negative times negative gives you a positive. So this would be a positive 9, and this would be a negative 9. Okay? See if you can figure out the answer to this problem right here. Hopefully, you said that this was negative 16, because 4 squared is 16, and then we have to stick on the negative side. This is not negative 4 times negative 4. Okay? There's one last thing that we need to do, and that's if we have to work with multiple kind of examples. So let's say I've been given 5x times x times 3y times x times 5y. We have to multiply all these things together. In this chapter, with exponents, there's a lot of multiplication that happens. And so when you have a lot of multiplication that happens, what you need to realize is 5x, the 5 and the x are not actually connected. 5x should really be written like 5 times x. So the first thing I'm going to do for this problem is I'm going to expand this, and I'm going to make sure that I don't have anything attached. So one thing that's really helpful is don't have anything in your brain that says these things are attached. They're all going to be separate. Now after you've got everything apart and separated, now we're going to reorder using the commutative property, which basically says, hey, you know how you have 2 times 3? Well, that's the same thing as 3 times 2. Like, the order of these things doesn't matter because we know both these things give us 6. So in this case, I know the order of these things don't matter, so I'm going to pull the x's together. So I can write x times x times x. Same thing with the y's. I'm going to pull the y's together. Same thing with the numbers. I'm going to pull the numbers together. And again, the order that you pull these things together does not matter. You just kind of want the numbers to be together and the letters of the same type to be together. Well, this is actually pretty easy for us to do because it would just be 15 times 5, which it's a little bit harder for me to do in my head. I think it's 45. 75. Whoops, a little bit off. Then this, hopefully you go, okay, what's x times x times x? Well, I'm multiplying x 3 times. So I am multiplying x 3 times. So my base is x, and the amount of times that I'm doing it is to the 3rd power. Same thing with my y. Y times y should give me y squared, because I have my base, or the thing I'm multiplying, and I'm doing that 2 times. So my final answer, if we kind of combined everything together, would look like this. Now, it's easy to write this on paper. This can be written a little bit differently on a computer and in our calculators. So if you ever want to plug this into your computer struggles with this subscript sometimes. So how we write this in to a computer is we make these little caret symbols. And that's how you kind of show it's an exponent. So when you have to type this stuff into the computer, this is how it would get typed into the computer. And these little caret symbols, which I don't know if I did the best job of trying to show, but it's that symbol right there. That's how it would be typed in. Try the different problems, and if you get stuck, please ask questions.